All right, Mike, that's the thing. I think that might be fun. I've decided to record a set of videos that I'm titling okay, I'm gonna cut this as well. I've decided to record a set of videos that I'm titling Addition is All You Need. And the reason I'm doing this is because I've noticed that there's some inaccuracies in the way addition and subtraction is taught in high school. I know this because, well, I was taught this incorrectly in high school. And not until college did I actually understand and was able to follow the logic. And I'm hoping this inspires others to, one, correct what is being done incorrectly, and maybe add some more context as well. So I know this still happens because I teach math at a math camp in Guyana, and I ask the students the following question. What is the sign of 2 in this expression? And overwhelmingly, if not everyone, said that the 2 is negative, which is not true. This is a positive 2. However, in Guyana, it is taught that addition has a higher precedent than subtraction, and so you have to do addition first. Now, if you were to do the addition first, you'd actually get it incorrectly. You would not get the correct answer if you did addition first. But what they do to get the right answer is they consider this 2 to be negative, which is not wrong. This is something you can actually do, but there is something missing from the explanation. So this is how it's done. This is how I was taught, and I believe this is still how they do it. In Guyana, I can only I went to high school there, so I can only speak about how it's done there. So they say, well, I have to add first, and they do. So they bring the 5 down, right? And they say negative 2 plus 3 is 1. And they add 1. They get 6. This is the right answer. But this explanation is lacking. Here's why. Let's do another example, but let's change subtraction to addition. Right? So I have 5 plus 2 plus 3. All right, well, I only have addition, so I do the first addition first. So 5 plus 2 is 7. And then the operator that I did not use, which is addition in this case, I bring that operator down. And the number that I didn't use also comes down. So 7 plus 3 is 10. Right? Let's do another example. Again, let's have the same operation. So we do subtraction this time. 5 minus 2 minus 3. The operations are the same. So I do the first one first. 5 subtract 2 is 3. The subtraction that I don't use, I bring it down. If 3 minus 3 is 0. Let's do one more example. So this time we'll do 5 plus 2 minus 3. Well, you do the addition first. 5 plus 2, 7. Then the operator that I do not use, bring that down. In this case, it's subtraction. 7 minus 3 is 4. Right? So we see a clear pattern in these three examples. But that pattern is missing here. The claim is I do the addition first, but I have the subtraction operation that remains. Where does that subtraction operation go? It just disappears. Or you say, oh, the 2 is negative, but if the 2 becomes negative, what operation then is happening between the 5 and the 2? Right? How does it match? How does addition as an operation magically appear here? Here's what really happens. And they really opt to include this. The truth of the matter is, when I subtracting a positive number, it's the same, has the same definition in mathematics as adding a negative number. And subtracting a negative number has the same definition as adding a positive number. I'll go through that in a different video, but this is what you're actually doing. I repeat that. Subtracting a positive is the same as adding a negative. Now, addition as an operation is associative, right? Now, just remind us what it means for an operator to be associative. Here, addition. What it means is I could choose to combine the first addition first, and then take that result of the first addition added to the last number, or I can choose to combine the last two numbers first with addition, and then add on the first number 8. Right? So this expression, if I want to combine the last two first, the -2 and the 3, first I can do this. Right? And now this 5 will come down. I'm not going to use this addition operation yet. So this addition operation comes down. This is what's missing. And now, remember I said adding a negative is the same as subtracting a positive. So adding -2 to 3 is the same as subtracting 2 from 3. So that means I will get 1. And this is the addition. 5 plus 1, 6. Now, what you should clearly see is because addition is associative, and I just said adding a negative is the same as subtracting a positive, it cannot therefore be that addition would have a higher precedence than subtraction, because I can represent subtraction as addition. And because I can do that, subtraction and addition have the same precedence. And what you're taught, so that you don't do this, is you should do subtraction first and then addition. Right, so this is what I see a lot of videos online saying, that addition and subtraction have the same order of precedence, do them left to right. So 5 minus 2 plus 3. 5 minus 2 is 3 plus 3 is 6. Now, this is great. I'm glad a lot of videos would say this. However, there is still a problem with this. And that is why I think even if you do it this way or you teach this, you should also teach this. Because this is needed for algebra. I'm sure we all remember learning that addition is associative, but we never really learned why we cared. Here's why you care. And here's why you still need to teach this. When you get to algebra, you have the expression x minus 2 is equal to, let's say, 7. And then the teacher tells you, well, do add 2 to both sides. Now we know 7 plus 2 is 9. Then they tell you negative 2 plus 2 is 0. Where does the negative come from again? This is confusing. This is not a negative 2, this is a positive 2. And you taught me that if subtraction is first, I do subtraction first. But if when subtraction comes first, I have to do subtraction first, I cannot solve this problem because I don't know what x is, so I cannot subtract the 2 from it. And I cannot add the 2 first because, like you taught me, whenever I have subtraction and addition, I have to do subtraction first. All right? So magically making this 0 is what you're actually doing a magic trick here, and that's confusing. However, if you were to teach kids that subtracting a positive is the same as adding a negative, now you have addition, and addition has this beautiful property. Addition is associative. So I can do the second addition first. Remember, adding a negative is like subtracting the positive. So I started the positive, and if I subtract 2, I move 2 places to the right, that will give me 0. Right? So I have x. This addition that I'm not going to use, it comes down. This follows what we've been doing all along. Negative 2 plus 2 is 0. So x